Today we're looking at note 6.3, transformations of square root functions. So for the notes, we're going to graph each function, give the domain and range, x and y intercepts, and max and min over the interval 1 to 4. So the parent function, the square root parent function, y equals square root of x. Let's talk about it. Thinking about x values, possible x values to plug in for the table, a lot of our parent functions start with -2, -2, -1, 0, 1, 2, such as absolute values, such as quadratic. But think about it. If I take -2 as an x value and plug it in for x, what kind of y value is going to come out? If I have square root of a -2, it's going to be an imaginary number. Likewise with -1. So what's the first x value that I can plug in for square root that would not produce an imaginary y value? I hope at home you're screaming 0. 0 would be the first value for x that I could plug in. The square root of 0 is 0. The next value that would be nice to plug in here would be 1. The square root of 1 is 1. I wouldn't want to plug in an x value of 2 because the square root of 2 is a decimal value. Also same for 3. But if I plug in 4 for x, the square root of 4 is 2. You could also go up to 9 and 3. But a lot of the time that point won't fit on the graph because you don't have enough room. But just be aware, of course, it's going by square root, so that's how you would get the remaining values. Okay, so we're going to plot 0, 0, 1, 1, and 1, 2, 3, 4, 2. And those will be the 3 points that I really need you to have for every single graph. This fourth point won't be required every single time. Okay, so now let's talk domain and range. So the domain of this graph, because it starts at 0, is going to be x such that x is all numbers greater than or equal to 0. It's going to go on forever to the right. So you would write that in interval notation saying it starts at 0, goes to infinity. Starts at 0 and includes 0, and goes to infinity. For the range, it's similar. It starts at 0, goes up to infinity. So y such that y is greater than or equal to 0. And then for interval notation, same, from 0 to infinity. That's a bracket. Okay, the x-intercept and the y-intercept are both 0, 0 for the parent function. Goes through the x and y-axis at the origin. My max and min over the interval 1 to 4. So we're talking from 1 to 1, 2, 3, 4. So my max is y equals 2, and my min is y equals 1, as you can see. All right, so just like all the other parent functions that we've dealt with this year, the -5 on the outside shifts the graph down 5. So 1, 2, 3, 4, 5. That's my new starting point, and from there plot the original x and y values. So 0, 0, 1, 1, and 1, 2, 3, 4, 2. I won't make you include 9, 3. Okay, and then from there, my domain, it has only shifted down, not left or right, is still the same. X such that x is greater than or equal to 0. 0 to infinity for interval notation. My range, y such that y is greater than or equal to now -5. And then -5 to infinity for the interval notation. My x-intercept, quite a bit more difficult to find because it has shifted down 5. So for this one, we'll have to do a little algebra. You know that the x-intercept is the point on the graph that has a y value of 0. So if I plug in 0 for y here and solve, okay, I would add 5 to each side, add 5, add 5. So 5 equals the square root of x. To get rid of the square root, I would square each side. So 5 squared is 25. And so I've solved for my x-intercept. So my x-intercept is 25, 0. My y-intercept is easy to see. It's 0, -5. Okay, and then my max and my min can be seen if I draw the lines, the interval from 1 to 1, 2, 3, 4. Okay, so my max is going to be y equals -3, and my min is going to be y equals -4. Okay, and number 3, we have y equals square root of x plus 4. Notice that the plus 4 is inside the radical. So a plus 4 inside the radical is going to shift the graph horizontally. We're going to move left 4. So 1, 2, 3, 4. That's my new starting point. From there, plot my 1, 2, 3, 4 original points from the parent function. And again, we don't really need to include, but we can, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Sometimes it's nice to see, but you don't always have to include it. Okay, so there's that. Now, the domain of this one is going to be x such that x is greater than or equal to -4, and interval notation -4 to infinity. The range, y such that y is greater than or equal to 0. Okay, so 0 to infinity. And then my x-intercept is going to be -4, 0. My y-intercept ended up nice and clean on there, 0, 2. And then let's talk about the max and the min. So on this one, we're going from 1 to 1, 2, 3, 4. Okay, so on this graph, you'll notice the max and the min didn't end up on nice, clean, whole values. So again, we're going to have to use algebra. We know the max is here on this orange line and the min is here on this orange line. So we are going to plug in these x values here to find out what the y values will be. So to get the max, the x value here is 4. So if you plug in 4 for x, you would get 4 plus 4, which is 8. So it's going to be y equals square root of 8. That's our max. Our min for this graph is going to be y equals, plug in the x value of 1. So that'd be 1 plus 4, which is 5. So it'd be y equals square root of 5. Now you have to be aware of who your audience is. Some audiences will be okay with you leaving the answer like this. Some will want you to convert it to a decimal. For now, I'm okay with this, unless I ask otherwise. Okay, so let's look at this graph. You're familiar with if you have a number on the outside being multiplied by the parent function, that's a vertical stretch. So in this case, we're going to have to actually mess with our table. So we've got 0, 0, 1, 1, 4, 2, and 9, 3. I guess we'll just keep it. And the 2 on the outside means we're going to take our y values, multiply them by 2. So this would become, or stay, 0, 2, 4, and 6. All right, so we haven't shifted any, so we're going to stay at the origin, 0, 0, 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 9, 4, 5, 6. So that one's going to go like that. All right, so I'm going to go ahead and draw in my lines for the max and min from 1, 2, 3, 4. I'm going to draw in those lines, okay? Talk about domain and range. So domain x such that x is greater than or equal to 0 goes from 0 to infinity. Our range, same. It hasn't shifted any. So, of course, the domain and range are going to stay the same. Greater than or equal to 0, so 0 to infinity. Okay, again, same. It hasn't shifted, so our x and y intercept is still 0, 0 for both the x and the y intercept on this one. And then our max and our min, max is now y equals 1, 2, 3, 4. And our, oops, hello, didn't write it. And then our min is y equals 2. So nice whole numbers on that one. Okay, so here, what have we done? We have put a negative in front. Remember that means a reflection over the x-axis. So again, something like that, you're going to want to look at your table of values, which is 0, 0, 1, 1, 4, 2, and 9, 3. Multiply your y values by -1. So everything turns negative except 0, of course. So our new points are 0, 0, 1, -1, 1, 2, 3, 4, 4, -2, excuse me, and 9, -3. So I'm kind of turn it to make sure that curve turns out pretty nice. There we go. And then Now talking domain, the domain remains the same. It's still, the arrow is facing to the right. So x such that x is greater than or equal to 0. The range, however, is what has changed. Now my arrow is facing downward. So y such that y is less than or equal to 0, which means my interval notation will be negative infinity to 0. Okay, and then my x and y intercept actually will stay the same. It's still the origin for both. Okay, and then let's look at the max and the min. Max, min. Okay, we're talking still 1 to 4. So my max is y equals negative 1, and my min is y equals negative 2. All right, so last one, putting it all together. So we have a reflection, a shift right 2, and a shift up 1. So the graph goes right 2, up 1. I'm going to deal with that first. And then we know it's been reflected. So don't reinvent the wheel. You already have that table over here. So with a reflection, I'm going to plot at 0, 0, which I already have. 1, negative 1, 1, 2, 3, 4, negative 2. And like I said, that 9, 3 point won't fit a good deal of the time. In this case, it doesn't. So I graph that graph, and I'm going to look at the domain x such that x is greater than or equal to starts at 2. So from 2 to infinity. The range, again, is going down. The graph is going down, so y such that y is less than or equal to 1. So from negative infinity to 1, with 1 included. Okay, and then the x-intercept, nice whole value, is 1, 2, 3, 0. The y-intercept, kind of draw a squiggly, on this one is actually non-existent, not applicable, non-existent. Okay, and then the max and the min on this one, we're talking from 1 to 1, 2, 3, 4. All right, so the max is y equals 1, and the min is this value right here. That's as high as it goes, that's as low as it goes. As low as it goes is not a whole value. So again, we have to plug in. We know the min occurs where x equals 4. So if I plug in 4 here for x, I'm going to do that off to the side here. So y equals negative. Plug in 4 for x, 4 minus 2 plus 1. So that would be y equals negative. 4 minus 2 is 2 plus 1. So leaving it like this for now, negative square root of 2 plus 1, that's fine for me. If you wanted to, go ahead and give me a decimal approximation to 2 decimal places. That's fine as well.